grade 11, grade 12 physical sciences. I welcome you to today's lesson. We are going to look at force diagrams and free body diagrams. So I'm going to do maybe 5, 6, 7 examples where one is required to draw a force diagram or a free body diagram of an object on a surface. I will only do one example of a force diagram, but the rest will focus on a free body diagram. Let's start with the first one. Here you can see a box on a surface. A block rests on a surface. It is not moving. You can see that the box is resting on a surface. How do I represent the forces that are acting on a box? The forces that are acting on a box while it is resting on a surface. The first one here is a force diagram. For a force diagram, you just draw a box. Then you represent the forces that are acting on a box. This is a force diagram. Free body diagram, you draw a dot. As we move on, I'll be using a dot, and you must know that is a free body diagram. If you have to convert that to a force diagram, you just have to replace a dot by a box. So now let's come back to the forces that are acting on a box, which is resting on a surface. There is no frictional force. There is no applied force. The only forces that are acting on this box are vertical forces. A normal force pointing up and a gravitational force pointing vertical downwards. These are the two forces that are acting on this box. For a free body diagram, we replace a box by a dot. Same forces, normal force, and gravitational force. Make sure that you name your forces. Let's move to the second example. A block on a surface with applied force. This one now is being pulled to the right. The forces that are acting on this block, we have a normal force, Fg, applied force, and frictional force. As this box is being pulled, there is a friction between the box and the surface, which is opposing the applied force. That force which is opposing the applied force is called frictional force. So it acts in the opposite direction, opposite of Fa. That's why we have Fa pointing to the right, Ff pointing to the left. What about if we have two boxes and there's a string between them and it is being pulled to the right, for example? So we want to identify the forces that are acting on these two boxes. Let's start by showing the one that are acting on A. Put a dot here to show that this is a free body diagram. We have normal force, which is this one, Fn. We have Fg. You can see that there is a frictional force here. There is applied force. This applied force affects A and B because they are attached by a string here. So because these two boxes are being pulled to the right, there's a frictional force between the block A and the surface. Here is the force, and it is acting against the applied force. Another force is the tension, force. This force, you can see that the applied force is, the direction of applied force is to the right. It means that box A is being pulled by this string to the right. That's why our tension force is pointing to the right, is pointing to the direction of applied force. Now, let's look at the forces that are acting on object B or block B. F normal, Fg, the applied force, correct? Here, remember, we have a force which is being applied on B by the string. As Fa is pulling B to the right, B, because it is attached to A, as a result, it will pull also A, but A will be resisting. As A is resisting, it will be pulling B to the opposite direction. So the tension, the Ft on B will point to the left. The Ft on B will point to the left. That's why we have Ft pointing to the left here. Again, between B and the surface, we have frictional force. Frictional force will point to the opposite direction of Fa. Here we have frictional force. We are moving on. Now we are going to look at this one. Forces acting on the objects A and B, same as the previous one. The way we show the forces of A will be the same as the forces on the previous example, but the difference here is that for B, the applied force now is no longer parallel to the surface. It is at an angle theta. So this Fa must be drawn the way it is indicated in the original question. You can see my Fa at an angle here. Fa is at an angle. Fn, normal force, Fg, Ft, and Ff. What about if we have a diagram like this one? We have object A and B attached by a string. How do we show the forces that are acting on object A and B? For A, there is normal force. There is Fg. F normal, let's put it here. F normal, then Fg. There is Ft. Remember, between A and B, there's a string and there's a tension here. There's tensional force here. So here, my Ft will point to the right. Remember, the B is pulling A. So tension force will point to the right. And then as B is pulling A, there's a friction here. So it makes it hard for this A to be pulled. As a result of this string, there will be a tensional force pointing up to show that there is a resistance which is being caused by A. So for A, our tensional force will point to the right, like what I've indicated here. And then for B, I've already said that the tensional force will point upward. It will point upward, and then the force which is pointing downwards here will be Fg. Here is another example. This time we are going to look at an object which is on an inclined plane. You can see that our surface here is at an angle theta, and we have an object which is on the surface which is at an angle theta. So how do I show the forces that are acting on this block? Remember, here we don't have applied force. We don't have applied force, but we've been told that the body is accelerating downwards. This is not a force, it's an acceleration. So how do I show forces that are acting on this object? Fn, normal force. Remember, the normal force must be perpendicular to the surface. Normal force must be perpendicular to the surface. And my normal force will be drawn from the surface to this direction, like what I've done here. Because it is accelerating downwards, there is a frictional force which is pointing up the inclined plane. And our Fg is always pointing vertically downwards. Another example of an object which is on an inclined plane. This time we are told that we must show the forces acting on a stationary object on an inclined plane. This object is not moving, is stationary. How do I show the forces that are acting on this object? Fg will always point vertically downwards. Let's see what's it. F normal. Oh, sorry. F normal is pointing or is parallel to the surface of the inclined plane. And then frictional force. Frictional force will be pointing up with the inclined plane. Another one, forces acting on an object being pulled up the inclined plane. Now in this one, we are told that the object is being pulled up the inclined plane. Let's show the forces. F normal is perpendicular to the surface. Here is F normal. Fg always point vertical downwards. Here we are told that it's being pulled up the inclined plane. So we have Fa, applied force. And we also have frictional force, which is pointing down the inclined plane. So this knowledge of drawing free body diagram will be very useful, especially when solving problems under Newton's second law.